Hello, we're doing a little tutoring session for Math 084 today. Thought we would get it kicked off by kind of going and showing everybody around a little bit again in Canvas, because I'm new to Canvas and I'm sure some of you are still kind of getting used to it as well. So you're going to find your classes. Yours look different than mine because mine are all math classes, but here's our 084 class. You'll click on that. Now this is what it looks like to me. So it's going to look a little bit different to the student. Let me put it on student view and just see what we can oh geez, how this will look for all of you. Okay, so if we go, there's our simple syllabus, but the modules is what you're really going to click on to find everything you're going to need. So I listed, here's my Zoom that I'm doing on Tuesdays, / we're going to be scheduling some evenings here and there. And then you can get to Desmos Calculator from here, or you can get to it on your own just by going to desmos.com once you've got your login set up. The forums are going to be our discussions. I might try to rename that. Those are going to be our weekly kind of discussions on things. So if you haven't done the growth mindset, you would find that right there. There's going to be also quizzes weekly on all of our basic skills, because remember, this class is to help support you. It's kind of like somebody that builds a house, right? They're like, I learned how to nail a hammer and I put on some shingles, and then they went to do the shingles and they're like, I'm just not really as good at nailing as I thought I was. So they're going to go back and just nail, right? Hit the hammer. And that's what we're doing, is we're just going back and it's hitting some of those drills of like basic things over and over. So the first quiz that I put out there is due this coming Sunday, actually January 30th at midnight. It's a factoring quiz. And this picture right here, if you click on it, it shows you what it looks like. So you can see the instructions. They're going to be basically the same instructions every time. And as soon as you open this, the clock starts, which I didn't know that. You can see over here on the right of you can see right here on the right of my screen, I had 34 minutes and 29 seconds left when I took this quick picture. So all the quizzes will be timed. They're all going to be set up about the same way. If I find people don't have enough time, I'll extend them because this is my first time doing it. So you'll have 35 minutes. You'll click on this, see where it's in blue. You'll click on that link. And I think my first factoring quiz is just like 5 factoring problems. I'm asking you to set it up just like I've been doing in my notes, with the greatest common factor, how many terms, and explaining your work, and then final answer for each of those. So that's just kind of showing you how to do that. Then there's that first quiz. Chapter 1. So all of the supporting things I'm going to give you for each chapter is going to be underneath those chapter modules. So you can see here, anything where there's like a little rectangle with a pencil, that means it's an assignment. So there's the quiz up there, and then I have a factoring flowchart assignment. So I put a video for the factoring flowchart. If you want to print out your own factoring flowchart, which is awesome, I'm going to show it to everybody here in just a minute. And then there's a factoring flowchart assignment that I wanted everybody to do, showing me that you know how to use the factoring flowchart before you take that factoring quiz. So I'd like you to get that in. It's actually not due until the 31st, but I'd like you to get that done and turned in so that I know you know how to use the factoring flowchart and you can use it on your quiz. That's the idea, is that you're gaining some understanding there. Any questions, Kate, so far on?
Nope.
So that's basically where everything is going to be for our class. It's going to be right here in the modules. And like I've explained to everyone, I'm new to Canvas. And so I love how these modules are. But if you all think, hey, things would be easier for us to find if you set them up a different way, I am open to how other instructors have done them. This is just how my brain is thinking about organizing the material. Is here are all the weekly forums, here are the quizzes, and then per chapter, there will be videos for each chapter, and then probably like one assignment here or there per chapter, but it's mainly going to be quizzes over the basic topics we're really hitting home, and then weekly forums. And the forums, again, are for you all to learn things about yourself as a student, resources to the school, and success tips. That's kind of what we're learning in our forums. Okay. So the rest of today is going to be about, Kate had some questions on 2.4 on the inequalities with one variable. And I think you said 17, right, was the first one, Kate, that you were
Yep.
kind of stuck on? Okay.
Is.
So also, I wanted to remind everybody in the Math 084 class, if you click on any of my videos, it will take you to my YouTube site. And then you can just kind of go to my YouTube site any which way you'd like to. It doesn't have to be through Canvas. And you will see that even if you're not in my Math 104 class, that you will be able to see my Math 104 videos. And they're labeled Math 104 L 2.1, L 2.2, and so on. So you're always welcome to go watch my videos as well. Chances are they're going to be a little bit different than your instructor. And as a student, I always love seeing different teachers teach it because they teach in different ways. And sometimes it just helps click if you hear something in a different way. So number 17. Oh, yes. I love the fraction ones.
That's where it got me, was the fraction.
So I really am a big advocate of trying to clear out the fraction before we even get started, because the fraction just puts us in a tizzy.
Right.
So to clear out the fraction, why am I always having trouble with this? Okay, so to clear out the fraction, we're looking for the least common multiple that we can divide each of these by evenly. So I'm just looking for myself. You could just multiply them all together if you wanted, and it will work to come up with one. So 2 times 6 is 12 times 12 times 9 is 108. But I can also see 2 times 6 is 12. 12 is not a multiple of 9. 9 is not a multiple of 2. But I do see one. 2 times 9 is 18. And 18 is also a multiple of 6.
Right.
So I think 18 is a good one. I'm trying to keep it as small as I can, but
No, it's fine. Yeah, it's fine. I can see it okay.
But it could be you just do 2 times 6 times 9 and just do that if you wanted to. So 108 would have worked as well. So I'm going to multiply my entire inequality by 18, which means every term. So this term gets multiplied by 18. This term gets multiplied by 18, and this term gets multiplied by 18. Every term. And the idea here is that each of these denominators, 2, 6, and 9, will get eliminated. So then it's just a simpler equation to work with. So 2 divides into 18, right? Or 18 divides by 2. And we're left with 9. So 9 times 1 is 9. Greater than or equal to 6 goes into 18 by 3. So we have a -1 times 3 is a -3.
Oh, okay. So you multiply the top one after?
Yep. So because this is really being multiplied by 18, so I'm just canceling out 6 into 18, and then I have 3 left.
Got ya. And then you multiply it by the top. Okay.
Yep. Great question. And then 9 divides into 18, and I have 2 left. And so then I have a 2 times 2. So I have minus 4x.
3,
Mhm.
4. Okay.
Mhm. Okay, so this is much clearer for us to look at.
Oh, way better.
So when we kind of go back, I think it's page 110 in our book that did a really nice job going through how to solve equations. And the first step was always, let's eliminate any parentheses with the distributive property, which we don't have. Then we want to eliminate the fractions, which we did. And then we need to get all the x's to one side, which they are. I like mine on the left. So we'll worry about that in a minute. Because there's no really need to move them now because they're all on one side. So let's go ahead and get our constants to the other side, so that constants have to be on one side and variables on the other.
So you add 3 to both sides, right?
Excellent. Yes,
Okay.
right. Oh.
And then it would be 12
Mm-hmm.
and then -4x.
Yep, minus 4x. Yep. Then to undo this multiplication, we're going to use our division. So we're going to divide by a -4. And the one kicker with inequalities, the only kicker is when you multiply or divide by a negative, which we
You
are.
have to flip the sign.
Yep. So I always circle it and to remind myself, and then I'll just put the opposite sign down below, just because that, so if I go back like a check register, if I go back to see where I made a mistake or whatever, I can see, oh, yep, I did flip it.
Gotcha.
So it's gonna be a less than here, and then 12 divided by -4 is a -3, and then X. Okay, so reading it this way, it throws Mrs. Main off. It throws me off a little bit, Sarah. So I'm gonna just write it so X is on the left. So because this says that -3 is less than or equal to X. So I'm gonna write X on the left. So that means I'm flipping my sign, not because of the negative, but because I want X on the left-hand side. So it's really X is greater than or equal to the -3. They're just swapping places, and then I'm flipping my sign. Again, this is only because Sarah, me, Mrs. Mean, I have a hang up with my variable being on the right. We all have bugaboos, and this is my bugaboo.
Yes, understood. No worries.
Okay, so once I have that, then it will help me. We're going to draw the answer on a number line, and we're also going to put the answer in interval form to practice both. Okay. So for me, I'm not sure of their instructor's expectations, but for me, I just mark my 0, and then I'm going to mark where my -3 is, because that's my boundary, which is to the left of 0. And again, as an instructor for this particular kind of problems, I don't get hung up on having a bunch of -1, -2, -3. I just want to know kind of where is it as a perspective to 0.
A left or a right, yeah.
And because it's an inclusive, meaning it's greater than or equal to, I'm including -3 as a possible answer. So I'm going to give it a colored in circle here. And it's all X is greater than or equal to a -3. So everything to the right. So we're going to just shade everything to the right.
Yeah, that's what I got.
Okay. And then once we get the number line, I kind of just parallel my interval notation right with it, because it's colored in. So I have a bracket.
Yeah.
So when I'm including with the equals, I get a bracket, and it's always your minimum on your left, comma, your maximum value on the right. And so my minimum is the -3, comma, my maximum, I'm limitless out here at a positive infinity. So there's my answer symbolically with my letters, with my algebra. There's my number line, and there's my interval notation for number 17.
Okay.
Next one.
Yep, that's what I've got. That one actually I got after we got to where I could break them down.
You were
It
good?
made it a lot easier. Yeah, because that was the hardest part once I got to the
Right.
whole the fractions. That's where it threw me for a loop.
Awesome. So what if we did 21 or 25?
Yeah, that's fine. I'm going straight in order on these ones. So we can do 21. That's great.
Okay, so let's do it. 2, there's X -3 less than 1. So because we have the fractions, let's eliminate the fraction. So what can we multiply? What least common multiple? The cool thing is there's only one denominator.
Right.
So I'm just going to multiply by that.
Okay.
So the way my brain is not the only way to think by any means, but just one way I've always thought about it is I'm just basically tripling my recipe. I'm thinking of this like a recipe of all different ingredients. And if I triple this recipe, I can use all whole cups. That's my goal. I don't want to use 2/3 cups. It's kind of awkward. So I'm going to triple my recipe. So I'm going to triple every ingredient. So I have to triple that I have to triple that, and I have to triple that. So every term gets tripled.
Oh, I got you. So 3 here
Mm-hmm.
with the X inside and then 3 cubed.
Oh, well, it's multiplied by 3. I just don't
Or
think.
multiplied by 3.
Yeah.
Yeah, that's what
No, I'm glad you brought that up because students might be thinking I'm cubing. Nope, I'm just multiplying by 3. So this, the 2/3 multiplied by 3, those 3's cancel. So I'm left with 2x. And then this is a minus 3 times 3. So I don't want that to be misled. So I'm multiplying this term times 3. So that becomes a minus 9 less than, then the 1 gets multiplied by 3. So I have 3.
Okay. I think that so far is what I've gotten trouble with was the parentheses, because once we break it down into that, I'm usually pretty well to where I can get to where I need to go.
Okay.
Usually. Because you do. Okay.
And we have Jordan here.
Okay, so then we do what, +9 on both sides, right?
Yes, ma'am.
+9, so 2x plus 12. And divide by 2, divide by
Mhm.
2, x is less than 6.
Yep, so x is less than 6, and we didn't divide by any negatives, so we're good to go. So x is less than 6, and then we need to put that into the number line form.
Yep. And then 6.
So, and then my 6 is a strictly less than, so I'm going to have an open circle, and then I'm going to shade it to the left. And then again, like we mentioned up here, for the interval notation, we're looking for the minimum it can be and the maximum it can be. And
Mhm.
so on the right, I already know the maximum is 6. It's a
Right.
strictly less than, so I have to give it a parenthesis. I can't include 6, but I can get really close. And then the very smallest it can be is I'm limitless on the negative infinity.
Gotcha.
Awesome. Very good. So I'll let you see if there's another one you want to work on, Kate or Jordan. Is there anything in particular you wanted help with tonight?
My big thing is just the factoring and trying to get that.
Okay. Did you get
You're
did you have a chance to watch any of the videos I have out there?
I was trying to watch them, but I kept getting confused.
Okay. Where do you know where you're confused at?
It's pretty much trying to get it to the point where you can start factoring it down. That's how I'm starting to get confused.
Okay. I'm gonna see if Kate, are you working on 25 or are you?
Yep.
Okay, so you're trying number 25.
Mhm.
Okay, so let's do one more with 25 and then we'll go back to some factoring because I know Kate wanted some more help on factoring too.
Yep, absolutely. I think I'm having the same problem she is. It sounds just like what I was having trouble with.
Yeah.
So it's not just you, I promise.
No, it's not. It is not.
Sometimes I feel like it is, though.
Understood, but I promise you, you are not the only one.
Well, that's good.
Yes, yes.
Okay, so when we're dealing with fractions, solving equations. Again, we're going to try to eliminate the fraction. So we're looking for a number that 2 and 3 can both divide into.
Be 6.
Yep. So not just the fractions get multiplied by 6, but just a reminder to everyone, every term. So this term, this term, this term, and this term all get multiplied by 6. 6. And then this gets multiplied by 6. This gets multiplied by 6. Not an exponent, but multiplied. And this gets multiplied by 6. So 6 times 4 is 24. Minus 2 divides into 6 3 times. So we have 3 times 1 times x. So that's 3x less than, and then 3 divides into 6. And we have 2 left. And so we have 2 times x is 4x. Subtracting 5 times 6 is 30. Mhm. So now all of our x's need to go on one side, and Mrs. May likes to have them all to the left. So since we have to move some either way, let's move them all to the left. So let's subtract 4x. So those add to 0.
0. So that's negative 30 here.
And then we're going to subtract 24. So I'm just going to rewrite this so we have room here. We're going to subtract 24 to put the constants all on the right.
Okay, yep.
And then we're going to divide by a -7. And because we're dividing by a negative, I'm going to circle that inequality because it has to get flipped over. So it's going to be a greater than. So it's going to be x is greater than, and it's a negative divided by negative. So it'll now be positive, and we can leave it as 54/7.
Okay.
Which is roughly,
That takes away the negative when you flip the side,
pardon me.
because that would take away the negative if you flip the side, correct?
Well, the reason it takes away negative is because we had a negative divided by negative.
Oh, got you.
Yep. And so this is approximately 7.71. So if we wanted to graph this on the number line, there's 0, there's 54/7, which is the 7.71. And it's greater than that with an open circle because we're not including it. And then it's greater than, so we're going to shade to the right.
Okay.
Any questions on those three?
No, not that I can think of.
That should get you going. Okay,
Hey, could we possibly do 28, 29 really quick? Because that one's got variables in the fraction.
29. Oh, wait, oops. Remove myself here for a minute. 2.4,
Yep,
29.
yeah.
Mhm. Oh,
'Cause
it's just the way it's written, but yes, we can.
Okay, perfect.
They just have it kind of written a little bit different. Okay, so 29. We have 3 minus x over 5 less than 5 minus x over 4. So to eliminate the fractions, we are going to multiply by 5 times 4. So we'll
20.
20. Yep. So I'm going to multiply 3 times 20. I'm going to multiply this fraction times 20. I'm going to multiply 5 times 20, and then this fraction times 20.
Okay.
And I'll be right back.
No problem.
Okay. Okay, so we have 20 times 3, so that gives us 60. And then this looks a little bit different, but it's similar to what we did before. So 5 divides into 20.
4 times.
Yeah.
So it'd be 4x.
Yep.
Okay.
So my
And then
works.
that. So 5 times 20 is 100.
Mm-hmm.
Subtract 4 times, or 4 divided by 20 is 5.
Yep.
5x.
20 divided by 4 into 20. I know it's the wording sounds. It's all kind of
It
weird.
does. So it's 60 minus 4x less than 100. Subtract 5x. Okay.
Mhm. Yep.
So it's not as hard as it looks. Okay.
And then again, we're going to put the x's on the left. So let's add 5x.
So 60 subtract 9x.
So we're adding 5x. So it's really
Oh, I
plus
lied.
1. Yep.
Yeah. And then 100.
Mm-hmm.
And then this is where we subtract 60.
Mm-hmm.
And then it makes it 1x 40.
Yep. So x is less than 40. And so there's 0, or 40 is over here on the right somewhere. And this is strictly less than, so we're gonna have an open circle at 40, and then we're gonna do less than. And so interval wise, it didn't ask for an interval, but we're gonna just do it anyway. So that means we can be as small as a negative infinity up to 40 with a parenthesis, because we're not including it. It's a strictly less than.
Okay. Gotcha. Okay. So these I think I'm pretty well decently comfortable on
You're good for that. Okay.
for the most part. Yeah. I do have a question though. If I do have like a couple of questions that I have, issues on, is it something that I can like email you and you can just email me back?
Yeah,
That way I don't have to set up a Zoom message for
Yeah.
2 questions.
absolutely. Anybody can email me at any time. You can text me through that Remind app. Oh, I don't know. Oh yeah, you're on the Remind app, Kat.
Yep.
Okay.
Yep.
So anybody that's watching the video, please sign up for my Remind message, because like I sent out a quick text tonight and said, hey, don't forget I'm doing a live session. So I'll do a lot of little reminders for everyone on things that when they're due, or when I'm available for things, or it's easy for you to quick text me. But if you're not signed up for the texting, then you're missing out on communication.
Oh yeah, it definitely helps because some people can't remember anything.
No worries. Okay, so let's go back to some factoring. Jordan wants some factoring practice too.
No
So
problem.
I know where Kate and I worked the other day, Jordan, but where can you give me a problem or two where you're stuck on in the factoring in 1.6?
That's on page what, 103?
77 is actually where the factoring is.
Brain, sorry.
That's right. So 103 is where we did the practice test, but those are like the hardest of the hardest. So that's where you should go back and watch the videos that I made for just factoring videos.
Yeah,
Yeah, the
definitely.
ones that I had the most problem with are like the smaller ones.
When you say smaller, like,
Like when they have only like 2 terms to them. Those are the
Okay.
ones that like really get me.
okay, so I'm gonna show you what I showed just earlier, but I'm gonna show again because you weren't quite on yet. Is in our Canvas site in the modules, besides the forums, there's a factoring quiz that is up there for this coming week. Also, just to remind everybody on the factoring quiz, on my quizzes, you'll take this one, and then if you're not happy with that score, I have more versions. I just don't want you to plan on taking those all right away. The idea is that we're going to keep improving ourselves. So you might get a whatever score in this first factoring quiz, and then I'll probably put up another version. So for anybody that wants to take it in the next week or two, you can go back and retake that again. So to where you're like, okay, now I'm confident I've got a good score in factoring. I can go on to the next quiz that I want to like keep improving on that area of my understanding. The next one will probably be on exponents. But here are my other
Okay.
videos down here. So the newest assignment that I have that I suggest everybody do before they take the factoring quiz is a factoring flow chart. And I'm going to show you how you can, this one that says factoring flow chart to print. You're going to click on this. And then I love this thing. I printed one out for myself and I wrote on it. So if you watch my video on the factoring flow chart, you'll see that. This flow chart kind of helps guide you, everything that we talked about, Kate, the other night, but it's much nicer than what we were writing down on paper. So if folks do not have a printer at home and there's no way for you to print, let me know. Email me your address. I will print one out and I will slip it in the mail to you. I don't mind at all, so that you've got a hard copy on paper. Please do that. But this is a nice way for you to walk through all of the steps to factoring. So the first thing we're going to do is always ask if there's a common factor, and then we're going to factor that out if possible, and then we're going to talk about how many terms. So I think Jordan said the ones where there's 2 terms are the ones that where she's struggling. And if there's 2 terms, there's only 3 possibilities. It can only be a difference of squares. So if there's no squares there, then that's not a possibility. Or if there's cubes, then it could be a difference of cubes or a sum of cubes. So how about we do, we go and do a few of these where they're these 2 terms. And then I can get particular on ones where everybody's kind of stuck. So let's do number 94 on page 78. And this is less than 1.6. So number 94 is a 81x squared minus 49y squared. So oh shoot, I already did this one on my video. I was going to say, I think I already did this one. That one's, let's do a different one then. Let's do 93. Because you can watch my video and get this one. So let's do 93. It's just a little bit different. 93 says 49x squared minus 64y squared. So the factoring flow chart that I will put in the mail to anybody that wants a copy. First thing I'm going to ask, is there a common factor? And there's only x's over here and y's over here. And 49 only has factors of 7, 7, and 64 doesn't have 7s as a factor at all. So the greatest common factor is a 1. Okay, so that's our question. So no, there's not anything besides a 1. How many terms are there? There are 2 terms. Here's one and here's one. So my only possibilities, so on the quiz that I put out there on Canvas, I even have it listed. What are your possibilities? Because I want you to be able, the more you force yourself to walk through this flow chart, the more confident you're going to be. So my only possibilities are these 3 right here on the left. And because ours has squares on X and Y, our only possibility is this top one. So I want you to be able to tell me why this is the only one that's possible. And that's because it's a subtraction and because we have X squared and Y squared, X squared and Y squared. So we need to see, can we make 49 into something squared? We can. So we can rewrite this as 7X, the whole thing squared. And I can also do the same with 64. I can write that whole thing as 8Y, the whole thing squared. And because I can write it as something squared minus something squared, I fall into this pattern. And I can just write that as the something minus something times the something plus something. A minus B times A plus B. So we can then say, I can factor this into 7X minus 8Y times 7X plus 8Y. And I'm done because the X and Y's all have an unsaid 1. They're not written, right? When the exponent's 1, we don't write them. But that's how we know we're done.
Can I ask you why it goes a positive and a negative, like a minus and a plus?
Why is it that way?
Mhm.
Okay, because let me do, okay, I know. So the reason it's a minus and a plus is because let's say we're going to check our work and we're just going to multiply this back together. We'll say 7X times 7X is 49X squared. And then 7X times 8Y is a plus 56XY. And then underneath we have a minus 56XY. And then a minus 8 is 64Y squared. And we can see that these two end up canceling out. They're plus minus of the same thing.
Correct.
So the reason we need them to be plus minus is because we need them to be plus minus of the same number. So they add to 0 because this, what we started with doesn't have anything in the middle. It's just two terms.
Okay.
So notice if I would have done a simple X minus 2X minus 3, right?
Mhm.
I get my X squared and then I get a minus 3X and a minus 2X in the middle plus 6. My middle terms are like terms, but they don't cancel out. So I end up with, oops,
5X instead.
right. I end up with that middle term there. But because this is a weird situation where they are identical but opposite signs, so they cut each other out. So you end up with just a difference of 2 squares instead of 3 terms. And so when you have just a difference of 2 squares, you know they have to have a plus and a minus so that they end up, those 2 terms end up canceling when you FOIL them back to check your work. You want them to cancel out. So you just
Okay.
end up with the squared on the front and the squared on the back.
Okay, that makes a lot more sense than what I was trying to make it out to be.
Same.
Okay, so this was just a little extra thing over here. Okay, so how about we do another one, and let's just jazz it up a bit. Let's do 90. Let's do 98. So 98 is X squared minus 25 over 36. And our greatest common factor is 1. So if we go to the flow chart, that really means it's a no. There's nothing that can come out. And how many terms are there? There's 2, right? An X squared and then this constant. And then because it's a squared and a minus, the first option, the difference of squares is the only thing we can do at this point, if we can get them into things that are squared. So we have X, that's a thing that's squared, right? So we have X squared. And then 25 over 36 looks a little scary. but 25 is the square of 5, right?
Mhm.
And
Yeah.
6 is the square of 6. So we really could just say this is 5, 6 squared.
Oh, yeah.
So I have something squared minus something squared, right? And so those factor into the something minus the something and the something plus the something. And again, it's so when you multiply and multiply, these add to 0. And so you're left with the first thing squared minus the second thing squared. Is that helping on those squares, on those weird difference of squares? Let's try 121. So 121 is 64 plus 27a cubed. And I'm gonna see if there's any greatest common factor. And there's not. 27 has just got 3's, right? 3 times 3 times 3, and 3 is not an even divisor or factor of 64. So that's not even an option. Okay. So how many terms? We have 2 terms.
Mhm.
Okay. It's a plus. So the things I'm looking at once I get to 2 terms is I'm looking at what is this, what is the operation? So it's an addition and it's a cubed. So let's go look at our possibilities. We have the squared, so that one's out this time, the one we've been using. This one is a cube, but it's a difference, so we can't do that one. So the one at the bottom is our only option. Okay, and that's the sum of 2 cubes. So if we can get something cubed plus something cubed, we can use this format. Something cubed plus something cubed. So it might be a little overwhelming for the cubes, but this might be a good little thing for you to make for yourself on a little piece of paper. Is a list of a bunch of squares and a bunch of cubes. So for the cubes, you could do 1 cubed on your calculators. 1, 2 cubed is 8. 3 cubed is 27. So that's going to be that one, right? The 27. So this one we can rewrite as 3a, the whole thing cubed. And then if you get a list of them, then they're kind of just handy for you to use whenever you're factoring. You're like, oh, I'm going to go to my list of cubes and see if any of these are cubes. 4 cubed is 64. 5 cubed is 125. And we'll kind of stop there for tonight, or at least for now. So 4 cubed is the 64, right? And that's what we have is 64. So we can rewrite that as a something cubed. So we now have something cubed plus something cubed. Everybody with me on that? So it fits our pattern of the last option on the 2 terms. The 2 terms is our last option, the sum of 2 cubes. So let's just write down what the format is. The format is a cubed plus b cubed falls into this format, a plus b, and then a squared plus, whoops, that one's minus, a squared minus a times b plus b squared. I looked down, so it's a subtraction. Okay, so this is the format we're using. So we have our A is a 4 and our B is this 3A thing. Okay. So just follow along with me. So we have, ours is going to fall into the format of 4 plus 3A. And then our A squared. So we'll worry about multiplying everything out in a minute. So our A squared is going to be 4 squared minus the A times the B. So our 2 something squared. I'm sorry, our 2 somethings multiplied. So 4 times 3A plus our second thing squared. So 3A squared. So I'm just going to go back over it again. Wait till everybody gets it written down. So you can kind of see my fingers. It's my A plus my B, right? My A plus my B. Then it's my A squared minus my A times my B plus my B squared.
Okay, that's where I'm getting confused, I think.
That's okay.
Oh, no. Okay, never mind. I see it. The 4 squared. I didn't see the squared up there. Okay.
And I'm gonna just write it out bare bones so that everybody can see exactly what is my A, what is my B in my pattern. So this is my A squared and then my A thing. When I say A, I'm referencing we should make them symbols like star cubed plus heart cubed. So we can literally, because we're not using those, right? We could say, okay, this is our star plus our heart. And then
Right.
star
It would be
squared
nice.
minus our star times our heart plus our star squared. Okay. So let's go ahead and simplify it out then. So our 4 plus 3A is as it is. And then 4 squared is 16 minus 12A plus 3A squared is 3 squared is 9A squared. And that's it. So if we go to page 103 and look at some from that chapter 1, because my class, Kate, I asked them to work on the chapter 1 test. So, and several of them did have struggle with these. So I thought I would just do some of these. And they're just kind of all kinds of factoring. Is that okay with you?
Yeah. Mhm.
Jordan, are you okay with that? Because I think that's what you were in particular asking about, right?
Sorry, what'd you say? Mom distracted me.
I said, I'm going to go to that page 103 on the chapter 1 test on that factoring, because I think that's what in particular you were talking about.
Yeah.
Okay, so let's go to the chapter 1 test. It's page 103. And we'll just look at 25. And these are kind of all mixed up, so it'll kind of help us go through our factoring flow chart. So 25 says 12x to the 4th plus 26x squared minus 10. And at any point, Kate, if you want to work on something else, you can, and you can come back to us, like, don't feel like you have to stay right with this.
Okay.
Okay, so first thing we're going to do is we're going to see if there's a greatest common factor.
I don't think there is. I think it's 1.
You think it's 1? Can they're all even, so they all should divide by 2.
Oh, yeah, I didn't even.
So that'll simplify it a little bit if we can get that 2 pulled out. So let's divide out a 2. So if we do that, we'll have 12 divided by 2 is 6x to the 4th plus 26 divided by 2 is 13x minus 10 divided by 2 is 5. Oops, and that's an x squared. And this is kind of weird because we've only done x squareds and x's, not x to the fourth and x squareds, right?
Yeah.
That's kind of weird. So let's just do a little like substitution. Let's let u equal x squared. Okay, so I'm going to turn it into what we're used to seeing. Like I said, these problems are kind of like the trickiest of the tricky. So this is going to be, so x squared is going to be u. So this is really just going to be u squared, because if I put x squared in there, it will become x to the fourth, plus 13u minus 5. And we're worried about replacing that x squared back in a minute. So now we have something that we're familiar with. It's 3 terms and our factoring flow chart. It's 3 terms and we can factor into 2 binomials. The 2 will stay out here, but we're looking for something like this, right?
Yeah.
And we could do some guess and check. We got to find either it's going to be 6 and 1 that makes a 6, or it's going to be 2 and 3, but we can have some structure to that. So we can look at things that multiply. So factors of, now remember, so in my video, and everybody goes back to watch that, this 6 is our A, 13 is our B, and 5 is our C. So we're looking for A times C. So that's going to be 6 times that negative 5. So we're looking for factors of a negative 30, and we want them to add to make the B in the middle, the 13. So you might have already thought about those numbers already, but I'm just going to go through my list. I've got negative 1 and 30. I've got 1 and a negative 30. My 2 and 15 combination, right? Negative and positive, because they have to multiply to make a negative. So 3 and then 3 and negative 10. 4 is not, but 5 and 6 are. And so if I add them, this is going to be 29, negative 29, 13, negative 13, 7, negative 7, negative 1, and 1. And we need a positive 13. So this is my combo. All right. So we've got negative 2 and 15. So we have to, this has to multiply to make 5 out here. So I know that one of these is going to be 5 and one's going to be 1. And then the one that's the multiplies to make the 15 here for the negative 2 times the 15 has to multiply by a 3. So that's going to go out here. So we have to think about our FOIL multiplication at all times when we're kind of putting these together. And then my 2 is going to be right here on the 2u. So it's going to be a negative 1 and a positive 5. Yeah. So it's going to be 15 minus the 2. Okay, but u really is x squared. So let's just replace that back in. So 2 times 3x squared minus 1 times 2x squared plus 5. So because there's a square there, I kind of have to go back to the beginning of the factoring flow chart and just ask if I could break those down anymore. Any common factor? No. This one has two terms. So it could be a difference of squares. But 3 is not a perfect square of anything. So that one's done. 2 can't do anything. That one's done because it's not a difference of squares. This one, there's no greatest common factor. And it's two terms and it's an adding. So it's out automatically. Because the only thing with two terms that has the squares is a subtraction. So I know they're done just like this. This is like
Okay.
factoring of the factoring, like if you have been factoring for a really long time, like, so that's where I want everybody to take a deep breath. The ones on this chapter test are like hard. My factoring quiz, my first factoring quiz here is the basics. It is the 1.6 basics. Okay, so I'm gonna quiz you over that. I'll probably ramp it up and do a factoring 2.0 later on, just to kind of keep you going, a little bit of a challenge to see how everybody's doing on that. But these are for professionals. This one right here.
Yeah, because you totally lost me on that one. Totally lost.
Yeah, there is a lot going on in that one.
I was okay until we figured out like the -2 and 15, and then she like did the 3u minus 1. That's when I started getting lost.
Mhm. So the key with the factoring, when you have three terms and you know it's going to be like these binomials, is you have to think when you're doing it, you have to think about, if I were to multiply it back together, will I get back to my original? That's what you kind of have to think about when you're putting your numbers in there. Do these make the 6u squared? Do these two multiply to make a 15? Subtracting 2 gives me the 13 in the middle. So it's kind of a constant, like being comfortable, like checking yourself as you go. Either writing.
So our main goal with the factoring, sorry, I hate to interrupt you, is to go from our original problem to a simpler one, and then to try to take that simpler problem and take it back to the original.
Well, the goal is really just to factor it. Checking your work is always a good thing, because you should always be able to check your work in algebra. So checking your work to make sure it does go back to the beginning is just basically saying, I don't need Mrs. Main to grade it because I've already checked my work.
Okay.
But this is the final simplified factored version right here.
Okay.
We can do number 29 is a good grouping method one. We haven't done any grouping method ones yet. So 29,
Okay.
page 103 is x squared minus 10x plus 25 minus b squared. My greatest common factor is a 1, because there's only 10 and 25. There's not x's in every term, and there's not b's in every term. So again, my factoring flow chart, I have 4 terms, right? 1, 2, 3, 4. I have 4 terms. So my only option is this factor by grouping on the flow chart here. And factor by grouping means we're going to group 2 terms together, pull out that greatest common factor, and then group 2 together and pull out that greatest common factor. So let's do that.
And you always do that where the first 2 go together and then the third and fourth go together, right?
Usually they work out that way, usually. So these first 2 terms, their greatest common factor is an x. Oh yeah, this one. Oh, this is a special case. It's actually a special case that's on the fact. Weirdly enough, it's the special case that's on the factoring, on the differences on the factor by grouping. this one doesn't work with the regular grouping, which is so weird. I forgot about that. Because if we factor that out, we have an x minus 10 left. And with grouping method, you should be able to get the same thing left over here, but you're not, because they don't have anything in common, do they? So that's not going to work. But we can, for just a moment, we can see that this part of my polynomial, this factors as a trinomial, x squared minus 10x plus 25. And that actually, I'm looking, I can factor that into two binomials off to the side for a minute as an x and an x. And I can see that 5 times 5 makes 25. Those are my factors of 25. And if they're negative, they add to make a 10x. So they multiply to make 25 and they add to make 10x. -5 and -5. So this right here, these first three terms is really an x minus 5 squared, right? A something squared. Minus the b squared. And now this is an interesting one because it actually just created a something squared minus a something squared, which is actually took us from 4 terms to our special difference of squares special case. Because it's a something squared minus a something squared. Like I said, these ones from the chapter 1 test are the hill of the hill. Would not be on my test anytime soon, my 104. You'd have to ask your instructors what their expectations are as far as factoring at this point in the semester. I don't think it's okay. So this is our something squared minus our something squared. So we're going to say we have an x minus 5 minus b times an x minus 5 plus b. And
Is it x minus 5 because of the negative or negative 10x?
Yep.
Okay.
Because minus 5 and minus 5 add to make a negative 10 and they multiply to make a positive 25.
Got it. Okay. That's where I was getting confused at. Got it.
Yeah. So this was a special factor by grouping case. So all of the ones on the rest of the ones on page 103, those factoring are definitely more than what I would be expecting at this point. I'm kind of guessing more than what the other instructors would be expecting at this point too, but you would want to ask your instructor. So we could do another one that would be just for fun, because they're all for fun. And I'm on for another 11 minutes here. So we can at least get through another fun one. Let's do one that is more doable, but not so stressful. How about that? So let's do like 110. Problem 110. And it's on page 78. If you want to turn there, it's a grouping. So 3x cubed plus 2x squared minus 27x minus 18. So the general GCF is just a 1 because 2 and the 3 are both prime. So, and they don't both go in, 2 doesn't go into 27. So because we have 4 terms, we can do the grouping method. So we can group the first two and the second two. So the first two have an x squared in common, right? Is all, so we're gonna factor out an x squared. So we'll have a 3x plus 2 left over. Moving to that thing to, there, zoomed in, okay. Then the second two terms is minus 27x and the minus 18. They have a 9 in common, a factor of 9, right? You can both divide by, and it's got to be negative because notice this is a negative and a negative. So if we factor out a negative 9, 27 divided by 9, we have 3x, and 18 divided by 9 is 2. So notice whatever you have left over right here from the first grouping, you should have left over here from the second grouping. Everybody see that? So whatever we go, oh, they had this in common and this was left over, then this group should also have that left over. That's the idea of the grouping. So now they actually have this and this has 3x plus 2 in common, right? That's what the grouping does for us, 3x plus 2. And then what we have left over is this x squared here and this minus 9 here. Then we always ask ourselves, are we done? So that 3x plus 2 has a 1 on it, so it's done. But x squared minus 9, back to the factoring flow chart, has 2 terms, and it's a difference of 2 squares. And as you go and as you're doing more of these, you'll start to kind of see them, because this is x squared minus 3 squared, right? X squared minus a 3 squared. So it can factor into the special case of x plus 3, x minus 3. So that's one where the grouping method played out the really kind of the way it was. Most of us use it.
I'm super lost on that one.
That's good. You want to go back and look at it again?
So the part that I'm lost on is I see where you got the x squared. But what I'm not understanding is where did the plus 2 come from?
Oh, so
I see the plus 2 right here because it's the rest of the x squared, but I don't understand why the plus 2 goes on both sides, I think is what's confusing me.
okay, so let's look at just the first 2 terms up here in our original.
Mhm,
They had an x squared in common.
mhm.
So when we factor that out,
How is that? I don't understand how it's in common when it's an x cubed and an x squared.
so x
where
squared,
I'm
x
confused
cubed
at.
has that, it's got x times x times x, right? So this x cubed is really x times,
Oh, okay. So that's why it turns into 3x instead of the 3x cubed.
well, not, no, there's, the 3 is separate, but the x cubed is there's x times x times x, and the x squared is there's x times x. So they actually have x squared in common. They have x times x, x times x. So we can bring out x times x out front.
Okay.
And then they have the 3 and the 1 x left over.
So it's the 3x instead of the 3x cubed.
Right.
Okay, so that's where you get the plus 2 on the one side,
Yeah.
because that's all that's left. Okay.
Yep. And then the 2 terms over here, the negative 27x minus 18. Now I'm going to kind of cover this up and say, what do they have in common? And they have a factor of 9 in common. a -9. So I'm going to factor out the -9. So a -27 divided by a -9 leaves a 3x left. And then a -18 divided by a -9 leaves a +2.
Oh, okay. I gotcha.
And the more you do of the grouping ones, you'll start to see like, oh, whatever's left over here will always be what's ever left over here. They have to match.
Got it.
Because in a 3D form, then those kind of come off to the side and then they're the common thing, right?
Mhm.
So the more you do of those, it's like, oh, that totally makes sense now.
Right. See, and it makes sense. Like I said, when you go through it, it makes sense. But when I'm looking at it in a paper, it doesn't make any sense.
Right. You just have to kind of just try a couple, find some, try some more of those on the page 78, those ones like the 103 through the 112.
Mhm.
Y'all want to do another one? Is there another one on your list, Kate, for your class? Probably like 111 or else 109.
Yeah, 109, yeah.
Want to do that one?
Yeah.
Okay, let's do 109 for Kate. So 109 is 2x cubed plus 3x squared minus 8x minus 12. You still following along? Okay, Jordan.
Yeah.
Okay, so we're going to group these two terms and these two terms. So what do the first two terms have in common?
The x squared.
Yep. And then what do they have left over?
Is it x plus 3?
A 2x plus 3.
What is it? 2x?
Yep, 2x plus 3. I think this
Oh, gotcha. I see it
Okay.
now. Yep. So 2x plus 3. Okay.
Yeah. So when I'm thinking ahead for the next group, I'm already thinking ahead that this is what should be left over, right? 2x plus 3 should be left over here
Right.
when all is said and done. But let's just see how it plays out. So I'm going to cover this up and say, what do these two have in common?
4.
Yep. And they're both negative, so let's pull out a -4. And we need it to be a -4 so that it's a positive thing on the inside, right? We need this to be a 2x plus 3.
Right.
So a -8 divided by -4, sure enough, is a +2. Then we have the x. And a -12 divided by a -4 is a +3. Yay.
Okay, can you explain that second part again?
Sure.
The one with the 8, the 4.
Yep. So we're going to ask what they have in common, the -4. So I'll take a -8, divide out that -4, and I have a 2 left, right?
Mm-hmm.
And then the x.
-4 and then 2x plus 3. Okay.
And then the -12 divided by the -4 is the +3 left.
Okay. I think I got it.
Okay. And so then now we're saying what's in common between this grouping and this grouping is the 2x plus 3, right?
Right.
So let's bring that out in front, 2x plus 3. And then we have an x squared minus 4. The x squared is left there, and then minus 4 is left there. Some coloring is always therapeutic. Okay. And then we always ask if we're done. So the 2x plus 3 is done because it's down to this x has a 1 exponent. So that one's done. But x squared minus 4, because there's an x squared there, we're like, can we factor that anymore? And because it's 2 terms and it's a difference, it can be that maybe difference of 2 squares. And it's an x squared minus a 2 squared. So it's a something squared minus a something squared, right? X squared minus 4.
Mhm.
Then it can do that. It can make the pattern of the x minus 2 and the x plus 2. And since x is to the 1 and x is to the 1, they're all to the 1, they're all done then. They can't factor anymore.
Yeah, I mean, it makes sense now. I hope it makes sense tomorrow.
That's okay. That's where you're making progress. That's where you have to give yourself some grace. And I'll make sure Mr. Sandlin knows that, you know what I mean? You're making progress. You're doing exactly what you need to be doing. Frustration precedes growth. Frustration precedes growth. That is a true statement. It doesn't feel good
Yes,
to
it
be
is.
frustrated, but whenever you're frustrated, go, that means I'm on the verge of breaking through to something really good.
God, I hope so.
What?
I said, God, I hope so, because it's gonna be crazy. if not.
You are breaking through to something really good. I can just feel it.
I have 10 times more freaking chaos at work, and I can handle this 10 times better than algebra. That's the crazy part.
Jordan, do you
I'm
have
a
any
boss
other?
of like 62 people.